Okay, so selections are basically a way of checking the input or checking something and making a logical decision based on what the user entered. So, for example, in compute area, if they entered a negative value, that would be invalid, and a selection will allow us to check for that. Okay, Narisa, I will check and make sure they're both correct. The one on web access, though, is probably correct. Okay. So some of the things we're going to look at tonight is declare a Boolean variable, which is simply a yes or no um, answer. Implement a selection control using something called an if statement. Um, that's the most common, and there's a couple of different ways of doing it. Um, there's one way and two way, which is an else if or an if else, and multiple ways, which is all basically an if statement, but there are variations on the if statement. We looked at the math class last week, or Tuesday rather, when we did some of the mathematical calculations. I think when we did the payment, we used that. And again, that's like a class library of mathematical functions that don't work very readily, easily. They're more complicated than algebra, so they require um, a little extra help. And I compared it to the scientific calculator on the calc program if you had that, um, to let you do that. But in this case, we'll be using it to generate random numbers, which is the way most gaming programs work. Actually, they require this random function. Um, and we'll look at a couple of other new examples. We're going to look at how to combine combinations, what they call complex combinations, which is simply an if statement ask a question. But sometimes the question isn't as simple as one thing. Sometimes it's some combination of things being yes and no. So ands and ors um, are ways of doing that. And we'll look at some more examples of how we can implement that. The next sort of selection statement that's fairly common is something called a switch statement, which is sort of a modified version of the if statement. And we'll look at, again, more examples on how to do that. Formatting output with system.out.printf. I think I may have used that already on Tuesday, but I'll explain it further now. And we'll look at rules for governing operator precedence and associativity, basically order of operations, similar to math. And we will look at some more user interaction as well as some common debug techniques. So we looked at some data types on Tuesday, primarily the numeric data types, integer through doubles and floats and longs and all that sort of thing. And we looked at a character data type. I also kind of informally showed you the string data type. Tonight we're going to look at the Boolean data type. It basically is Boolean means true or false, yes or no. It's got two possible values. It's a lot like a bit being on and off. It's got two possible values. So we'll look at that. And that's all it stores. It looks at something on the right and says, is that true? If it is, then store true, usually 1, in the Boolean. And if it's false, it'll store false, or usually 0. And we look at some of the comparison operators. These are going to be very similar to what you would have seen in math. If you remember that, some of you are still in high school or recently out, so you probably remember all this. The Java operator is nearly identical to the math operators. There are a couple of differences. Less than and equal is done slightly differently, but it has the same meaning, as well as greater than or equal to, and then the not equal to. So slightly different. but it has the same meaning as it would in a mathematical operation. So we'll look at some examples here. This is an example I believe here already on essentially giving you two numbers and asking you to guess the outcome of those two answers. So if it gave you a question of what is 7 plus 9, then the student would need to answer what that would be. My Neptune's not coming out. Not responding. I'll just restart Neptune's. Oh, okay, here we go. So I'll give you a quick example here. Which might say, an if statement. We'll just do an int here. We say, what is 2 plus 3? And then the if statement would be if answer is equal to 5, then output correct. Else so we're going to prompt the user for some value, and then based on their answer, we're going to say either it's correct or it's not. So if I say 5, I get correct. Let's run it again. This time I'll put in 6, and I get wrong. Okay, so that's how that works. Does everyone see that? This is basically an if statement. So if the answer that they entered is 5, then we're going to do this. Otherwise, we're going to do this. So you're simply asking a question, and based on the question being right or wrong, you're going to give a different output. So, okay, well, here's one way, the if statement, basically to check and make sure they entered in a positive value for radius. So we can modify the compute area. Oops. This is the radius example we did on Tuesday. And this does the whole computation there, I think. Okay. So in this particular case, essentially if we give a negative value, we're going to get nothing. So if I come in and I give it a -2, there's no output at all. That's not really good. You want to give them output no matter what, but right, they're just simply not showing you the example, the else part yet. Very often we will try and diagram if statements with something called flowcharting, and it's a graphical representation. Or not triangles, but these diamonds usually are a decision. And you're generally asking a question like over here, radius greater than or equal to 0. If it's true, it does the computation above. Otherwise, if it's false, it doesn't. So that's sort of asking a question. Here's a couple of other situations here. A couple of other ones you could say, checking a number. If I is greater than 0, then I is positive. Here we've got an error because we don't have parentheses around the question or the if statement. You've got to have parentheses around it. And some others. Now what this thing here is saying is that you see the curly brackets, which indicates a block, and over here it's showing you not using it. Essentially with a lot of blocks, not all, but if you, in some blocks, including the if statement, if the command you're going to execute is a single command, just one command, you actually don't need the curly brackets. I don't like to confuse people up front, so I just show the examples with the curly brackets, and then eventually it's like one of those shortcut things. Once you get a little more comfortable, you can do it if you want. Okay, write a program that prompts the user to enter an integer. If the number is a multiple of 5, print high 5. If the number is divisible by 2, print high even. Okay, so we would want to do that one. Any questions so far?